Okay, so you've almost definitely heard of this one. You know, the idea that you can literally grow your intelligence, that your abilities aren't just fixed from birth, that if you just put in the effort, you can learn pretty much anything. It's called the growth mindset. And yeah, it has absolutely taken schools and businesses by storm. But what if I told you the science behind it is at the center of a really fierce, high stakes debate?
So let's just break it down real quick. The core concept is super simple and, let's be honest, incredibly appealing. If you believe you can improve, you will. It's this amazing message about human potential and just good old-fashioned perseverance. And that's exactly why you see it everywhere. From classrooms to corporate retreats, it just feels right, you know?
But this is where the plot really thickens, because when you start to dig into the actual evidence, the scientific community is, well, they're not on the same page, not even close. In fact, you could say they're locked in a battle over what the data is really telling us. And right at the heart of this whole controversy, you've got these two massive scientific reviews. They looked at the exact same body of research and somehow managed to come to completely opposite conclusions. It's a genuine scientific mystery. Now, these big reviews have a special name, a meta-analysis. You can think of it like a study of studies. So instead of just one little experiment, scientists gather up all the research on a topic, throw it all together, and use some pretty powerful statistics to find the overall trend. It's supposed to be one of the best tools we have for getting to the truth. And this slide just lays out the conflict perfectly. On one side, you have a meta-analysis from Burnett and their team. They concluded, yeah, growth mindset interventions work, and they work especially well for students that researchers singled out as at risk. But then, on the other side, McNamara and Burgoyne come along and say, hold on, those effects you're seeing, they're probably just illusions caused by bias and really sloppy research. So, who's right? All right, let's start with the argument for growth mindset. This has been called the culturally fluent view, which is a great way to put it. It flows with what we already want to believe, that hard work really does pay off. So the key argument on this side is that even if the effect isn't huge for everyone across the board, it seems to show up for the people who might need it the most. The idea is that researchers would pick a focal group, say students who are struggling academically, and for that specific group, the interventions seem to move the needle. But now let's switch gears and look at the challenging view. The one that's culturally disfluent because it pushes back against this popular feel-good idea. This is where McNamara and Burgoyne come in. They decided to re-examine all the research, but with a much, much stricter, skeptical eye, really checking for scientific best practices. And their first finding was, honestly, it's staggering. They found that a whopping 94% of the studies had what are called confounds. So what does that mean? It means the studies didn't just teach growth mindset. They might have also thrown in lessons on study skills or goal setting. So how can you possibly know if it was the mindset part that worked or something else entirely? The short answer is, you can't. Okay, this next one is an absolute bombshell. The researchers discovered that when a study's author had a financial incentive, we're talking selling books, giving paid speeches, that sort of thing, they were 2.5 times more likely to report a positive effect. That raises some serious questions about bias, right? And the list of problems just kept getting longer. They found that the better the study was, the more rigorous and well-designed, the less likely it was to show any benefit at all. They also found signs of publication bias, meaning studies that found no effect might just never see the light of day. A lot of studies falsely claimed they were pre-registered, which is a way to lock in your methods beforehand to prevent cheating, and most of them failed to do basic stuff like blind the participants and teachers. It's not a pretty picture. So just when you think, okay, case closed, the skeptics win, the story takes a huge twist. A third group of really well-known scientists, led by someone named Tipton, decides to jump into the ring. And they decide the best way to settle this is to reanalyze the skeptics' own data, basically to try and prove them wrong. And their conclusion was just stunning. They claimed that by using a different statistical method on the exact same data, they found that yes, growth mindset interventions did have a positive effect on at-risk students. It looked like a total knockout blow, a complete vindication for growth mindset. But the original skeptics, McNamara and Burgoyne, they came back with a devastatingly simple question. Was it really the exact same data? And in their reply, they showed that no, the data wasn't the same at all, not even close. For example, in one study, a negative effect where the control group actually did better was somehow flipped into a positive effect just by changing how they handled the starting scores.
In another, students they'd classified as medium risk were suddenly reclassified as low risk, which completely changed the outcome for the at-risk analysis. These aren't just minor disagreements, they're fundamental changes to the data. So here's the kicker. For McNamara and Burgoyne, this reanalysis wasn't a refutation of their work at all. It was a perfect example of the problem. They argued the new analysis made all these inconsistent after-the-fact changes that, surprise, surprise, just happened to produce a rosier picture. It was a perfect illustration of the very bias they had been warning about from the start. So, what are we supposed to make of all this? This whole back and forth is about so much more than just one popular idea. It's really a powerful lesson in how science is supposed to work, and why being a good skeptic is absolutely critical if you ever want to get to the truth. And the skeptic's paper doesn't just tear things down. It actually offers a constructive path forward, a recipe for better, more trustworthy science. They're calling for things like pre-registering your whole plan before you see the data, making sure your studies are actually big enough to find a real effect, using proper control groups so you know what you're actually testing, and of course, being totally upfront about any financial conflicts of interest.
And all of this leaves us with a really important question, one that goes way beyond growth mindset and applies to pretty much any appealing idea we come across. When something just feels intuitively true, when it's hopeful and inspiring, is that a sign that we should just embrace it? Or is that the exact moment when we need to be our most skeptical and scrutinize it even closer? The answer to that might just be the difference between what we wish was true and what actually is.